In this video, we will be taking a look at lesson 3, but this is the part 2 video. So in the part 1 video, we went over pages 2 through 4. In this video, we'll be going over page 1 and pages 5 and 6. So let's start on page 1 with some definitions. There are 4 types of data that you will need to be familiar with in our coding unit: numbers, strings, images, and booleans. So for now, don't worry about booleans. We'll talk about those later in lesson 7. But let's focus right now on numbers, strings, and images. So go ahead and pause the video now and take a minute to jot down these definitions, and then we'll take a look at some examples. So obviously we know that a number could be a whole number, a fraction, a decimal, so examples are pretty easy to come up with. 10 is an example of a number. 3.2 is an example of a number. 2/3 is an example of a number, and so on. A string is anything between quotation marks. So when we are trying to tell the computer to make something a specific color, we might use the string red. Or if we want to type a word like hello as a string, as long as you put it between quotation marks, it's a string. You could also take numbers like 42, for example, and put it between quotation marks, and instead of being a number, it's now considered a string. So a string is anything between quotation marks. And an image is, of course, a picture, like a picture of a star that is created by using the star function. The last couple definitions on this page deal with domain, range, and a contract. So go ahead and pause the video now and jot down these definitions. So the domain is the type of data a function expects. The easy way to think about domain is the domain represents the inputs into a function. The range is the type of data a function produces. So the easy way to think about range is the range represents the output. What type of data is the output? And a contract is a statement of 3 things about a function. The first thing is the function's name. The second thing is the function's domain. And the third thing is the function's range. So what you need to know about a contract is that there are 3 parts: the name, the domain, and the range. Now let's skip right past pages 2 through 4. We've already done those, and take a look at page 5. On page 5, it reads, below you will find 2 examples of functions that we have learned how to write in code. The first example is the addition function, which uses 2 numbers as its inputs. The second example here is our function star, which uses 1 number and 2 strings as its inputs. Notice that the different functions take in different types of inputs, and we need a way to keep track of the requirements for each function. This is where contracts are needed. So just to recap, a contract has 3 parts: the name of the function, the domain, and the range. So a review of our definitions for domain and range are shown below. The domain of a function is the type of data that the function expects. As we just mentioned, those are the inputs. So for example, the star function expects 3 things, 3 inputs in the domain. 1 tells the computer the size, that's a number. 1 of the inputs tells the computer whether to make the shape outline or solid, that's a string. And then the third input tells the computer what color to make the image. That should be typed in as a string between quotation marks. If the computer doesn't get what it expects with the star function, or any function for that matter, it's not going to understand. So we have to give the computer what it wants as far as when we use a specific function, we have to get the inputs right. The range of a function is the type of data that the function produces, in other words, the output. So for the star function, of course, it produces an image. It produces an image of a star. So let's take a look at the contract for our star function. The contract for our star function is, every contract begins with a semicolon, then the function name, in our case, star. then a colon, then the domain. So these three inputs here are listed, number, string, string, to represent the domain of our star function. Then we need an arrow, so that's made up on the keyboard of a hyphen and the greater than symbol. And then the range, or the output. In the case of the star function, the output is an image. So that's what a contract looks like. We use types for the domain and range instead of specific values when we write a contract because we want a contract to be a general description of how a certain function works. So we're not using a specific number, a specific string, and a specific string when we write a contract. We're generally writing what type of data is expected. So let's take a look at page 6 where we'll practice a couple different contracts here. So write the contracts for the following functions. The first has been done for you as an example. So for our function addition, we know that contracts begin with a semicolon. The function name is addition, a colon. The addition function takes in two inputs, specifically two numbers, and produces, which is what the arrow is indicating, it produces a number, a single number. So when we talk about multiplication, subtraction, and division, our contracts are going to look very similar because all of those functions take in two numbers as their inputs and produce a single number as the output. So for multiplication, the contract looks like this. We start with a semicolon, the function name is an asterisk, colon, there are two numbers for the input, and the output is one single number. So at this point you can pause the video and do the contracts for subtraction and division on your own. Go ahead and check your contracts for subtraction and division, making sure that your contract begins with a semicolon. That's very important. Let's talk about the square root function. SQRT is the computer's abbreviation or function name for square root. So when you think about when you take the square root of something, what's being used inside that square root symbol? We usually take the square root of a single number, right? So when we do the square root of 25, for example, we know that we can compute that answer or evaluate that answer and get 5. So something to keep in mind for the square root function when I write the contract is there's a single number used as the input. In this case, it was the square root of the single number 25, and it produces a single number as its output. In our example, it produced 5, a single number as its output. So that's the contract for the square root function. So I want to demonstrate for you how the square root function works because we have not seen this one before. So if I want to find or have the computer find for me the square root of 25, I just need to type in this code and it will evaluate it. If I want the computer to evaluate the square root of 256, it will do it for me using the square root function. If I want to evaluate the square root of a number that's not a perfect square, let's say, in this case we know we're going to get a decimal, and the computer will give us the square root of 800, in this case out to many decimal places. So that's how the square root function works. Let's go back to our packet and take a look at step 23 on page 6. Here's a new contract for a new function. In this contract we see starts with a semicolon, rectangle, colon, number, number, string, string, producing an image. So part A, what is the name of this function? The name of this function is, of course, rectangle, as shown right after the semicolon. How many inputs are in the domain of this function? There are 1, 2, 3, 4 inputs for this function, and the range of this function is an image. So the output will be an image for the rectangle function. So in letters D and E, I want you to take a look at the code that's shown and just think to yourself, what do you think the code is going to produce? And what are the similarities and differences between what D will produce and what E will produce? And then we'll take a look. So when I type the code for letter D into the interactions window in my software and evaluate it, I get a blue rectangle. What do you think the 100 and the 50 told the computer? We know from the star function that it tells the computer the size, but why did rectangle require two numbers? It's probably because a rectangle has a different length than it does width. So the 100 represents the length of this rectangle and the 50 represents the width. So I am going to copy and paste this code into the next line and take a look at letter E. Letter E wants us to use 30 and 30 for our two numbers. What do you think this will produce? It's still a blue rectangle, but in this case, because the length and width are both 30, it's actually a square. Now we can answer part D by stating that what we got was a blue rectangle, specifically a 100 by 50 rectangle. And in letter E, we got a blue, still a rectangle, but it was specifically a square because the length and the width were both 30. So that was a 30 by 30 rectangle, also known as a square. So down at the bottom of this page, there's a couple more contracts that are given that are all used to produce an image. So we see the ellipse function, the triangle function, and the circle function. So I'm going to demonstrate for you one example of each of those, keeping in mind that the ellipse function, which an ellipse is an oval, the ellipse function requires two numbers as the input because an ellipse will have a different length than it will have width, or it'll be longer than it is tall or taller than it is long. Triangle requires one number, circle requires one number. I'm going to first make an ellipse. Let's make it a solid pink ellipse. And the two numbers that I gave the computer are 50 and 100. If I copy and paste this and switch the 50 and the 100, what do you think that will produce? It produces the same size ellipse, except this time the length and the width, or the length and the height, are switched. How about a triangle? Triangle requires one number as its input, and I'll use solid again, and this time I will use maroon for my color. That produces a maroon triangle. And then lastly, our last contract is describing the circle function. Circle requires one number as the input, and I'll do a solid purple circle. And there we go. So the contract helps us decide what sort of inputs are needed and also gives us an idea of what sort of output to expect. At this point, this concludes our Lesson 3, Part 2 video.